Good morning, students. Earlier class we discussed about kinetic energy and expression for kinetic energy. Kinetic energy means the energy passes by a body which you of its motion is called kinetic energy. The expression for kinetic energy half mv square. Half mv square. Today, one of the important one we are going to discuss work energy theorem. Work energy theorem. We know that work. So work means when we are applied some external force on the object can displace along the direction of force. The work done by the force on the body. The work is equal to the product of force into displacement. What is called energy? The capacity to do work is called as energy. So work energy theorem. The statement of work energy theorem, the work done by a constant resultant force or any net force acting on a particle is equal to change in kinetic energy. Change in kinetic energy. If a work done on the particle by a resultant force or net force is equal to change in kinetic energy. The work done should be equal to change in kinetic energy. So this is called work energy theorem. The mathematical formula W is equal to W denoted by what? W is equal to half mv square minus half mv square. Half mv square means final kinetic energy. Half mv square means initial kinetic energy. So half mv square minus half mv square is change in kinetic energy. The work done should be equal to change in kinetic energy. So let us prove work energy theorem. Consider one object. The mass of the object is m. The object is moving in rectilinear motion. Okay. The acceleration of the object is a. The displacement on object is s. By using kinematic equation, v square minus u square is equal to 2as. We know that this equation. V square minus u square is equal to 2as. U means initial velocity, v means final velocity, a is the acceleration of the body, s is called the displacement. So the above equation multiply m by 2 in both sides. So m v square minus u square is equal to, again multiply m by 2 2as. Here we are multiplying the above equation both sides by using m by 2. Okay, so m by 2 into v square minus m by 2 into u square, that is equal to m by 2 into 2as. Here 2 get cancelled. So this equation may be written as half mv square minus half mu square is equal to mas. So half mv square, so v means final velocity. This is the final kinetic energy kf minus half mu square. This initial velocity denoted initial kinetic energy should be equal to ma nothing but f. According to Newton's second law, f is equal to ma. We know that f is equal to ma. So f into s, but f into s w, the work is the product of force into displacement. Instead of f into s, substitute w. Okay, so the work done should be equal to, W is equal to kf minus ki. Kf means final kinetic energy half mv square. Ki means initial kinetic energy. So the work done should be equal to change in kinetic energy. Change in kinetic energy. So this is called work energy theorem. So the work energy theorem can also apply for a system. So also apply for particle and also apply for a system. More than one particle, that is called as system. It is also applied for the system. The work energy theorem so also applicable for variable forces, conservative forces and non-conservative forces. Okay. So this is the one of the most important one, work energy theorem. So next one is conservative force and non-conservative force. What is called conservative force? The work done by the force around the closed path is 0. Okay. The work done by the force should be equal to 0. The type of such type of forces are called as conservative force. So work done by the force by a closed path is not equal to 0. That is called non-conservative forces. In the case of conservative forces, work done by a closed path is equal to 0. In the case of non-conservative forces, work done by a closed path is not equal to 0. Such type of forces are called as non-conservative forces. So examples of conservative forces: gravitational force is a conservative force, elastic force is a conservative force. Okay. Non-conservative forces, frictional forces and viscous forces are non-conservative forces. In the case of conservative forces, the conservative forces independent of path. Independent of path. So non-conservative forces doesn't depend on path of a particle. It will depend on a path of the particle. Conservative forces. Non-conservative forces doesn't depend on path of the particle. So conservative forces depend on the initial point and final point. If a particle moving one point to another point, the conservative force depend on one point to another point. Okay. But non-conservative forces doesn't depend on initial and final point. It depend on only path of the particle. Okay. So, what is called conservative forces? Which forces are acting on the particle? The work done should be equal to 0 in the closed path. Such type of forces are called as conservative forces. Which forces are acting on the particle in a closed path? The work done is not equal to 0. Such type of forces are called as non-conservative forces. What are the examples? In conservative forces, gravitational forces, elastic forces, electrostatic forces are called as conservative forces, and frictional forces and viscosity forces are called as non-conservative forces. In conservative force, it depends on the path of the particle, but non-conservative forces doesn't depend on the path of the particle. And again, the conservative force depend on the initial and final point of a particle. If a particle moves from A to B, so the A is called initial point and B is called final point. So the conservative forces depend on initial and final points, but non-conservative forces doesn't depend on initial and final points. It depend on path followed by the particle. Thank you.